Welcome to Education World YouTube channel. And today our topic is chemistry. And in the chemistry class today we will be discussing about the periodic table. Okay, so this is also known as the periodic classification of the elements. Okay, so before going to the details, so basically we'll discuss about the why we need periodic table. So basically periodic table contain all the elements that is known to us and that is available in our earth. Okay, so in the periodic table, so before going to the details, so basically a brief introduction about the periodic table. In the periodic table we are having 118 elements that is known to us, and among all these elements, so basically the 94 are naturally occurring and the rest are the artificial or we synthesize in the laboratory. Okay, so in the present or the modern periodic table, now we are having 118 elements that is known to us or it is present in the periodic table. Okay, so now you can imagine we are having a large amount of the element that is known to us or that is available to us. So it is it could be better to understand their physical properties, their behavior, if we collect them in a table. Okay, so that is why we need a periodic table. Okay, so and how, so before that, before going to the modern periodic table, so we learn about the brief the history or the background, how the periodic table developed. Okay, and how we got got safe, it got safe in the present days. So it start with Deborania. So basically the early classification, it's it is attempt was made. So the why this attempt was made, actually, the if we think about in our home, so basically we are having clothes, we are having kitchen stuff. Okay, so again, if you think about the clothes, so we are having clothes for the winter and the summer. So we did not keep all these clothes together, so we keep all these things in a different place. Okay, so again, if you think about the vegetables and the kitchen stuff, so basically in the kitchen, so we need vegetables and we need all the spices. We did not keep all these things together. Okay, so we keep vegetables apart in the side and we keep spices in the other side. So basically now this will help us to find the things quickly and to understand things, get the things and to understand the property of this. Okay, so that is the intention to make a periodic table, so that we will have all the elements together, and from there we could learn about those elements, their chemical properties, their physical properties, and reactivity, all these things. And to make the periodic table, so basically at early attempt it was made by the Lavoisier, so who first told the elements could be classified into two categories. So one is the metal and another is non-metal. So this is where it started. Okay, so when we knew about few elements, so then among the few, so he classified that one would be metal, one categories will be the metal, and the other categories will be non-metals. Then it started with the Deborania. So actually he first identified some groups, and which is called the each group contain three elements. Okay, so since the group contain three elements, and he gave the name the triads. Okay, triads means so each group contain three elements. Okay, and he made four triads. Okay, so these are the four triads he made. So first triads is the iron, cobalt, nickel. The second triad is like lithium, sodium, and potassium. And the third triad, it consists of calcium, strontium, and barium. And the fourth, it is no, it comprising chlorine, bromine, iodine. And what basis he made this triad? Actually, he made the, it is based on the atomic weight of these elements. Okay, so he proposed like the atomic weights are either nearly same, or the atomic weight of the middle element was roughly average of the atomic mass or weight of the other two. Okay, so if we think about the first triad, so the atomic weight or atomic mass of iron, cobalt, and nickel are pretty much same. That is, the values are given here. If we think about, or if we consider the this second group, so basically it consists of lithium, sodium, and potassium. So basically if you take average of 7 and 39, so we'll get the average value 23, which is the atomic weight of sodium. Okay, in the same way, we can understand about the atomic weight of strontium and the barium, bromine in the third and fourth triads. Okay, so this is very important for the early stage of the periodic table. So basically, the competitive exam, so you can get a questions. So many questions you can get. The first things that you can get, that how many triads no Deborah made. So basically this is a three four triads. Okay, so then this is very simple question, but the most important question, so like a you have to now we know, so this chlorine, bromine, iodine, so this belongs to the halogen group. We learn this about in later stage, but in the beginning, so we see like a we are familiar with this. So this is a halogen group. Okay, so but Deborah, so he identified in the halogen group only the three elements. Okay, the chlorine, bromine, and iodine. So in the question, so you may think about like this. So which is not a Deborah triad. So in the option, so maybe the options will be given like a fluorine, chlorine, bromine. Okay, and maybe the calcium, strontium, and barium. So these are the, so out of these two, which is or which is the correct triads, Deborah triads, or which one is the wrong. So basically again you have to remember, so the triads are made for the, this one is chlorine, bromine, iodine, not the fluorine. At the same time, when we talk about this, so basically it is not, maybe in the exam you may see the options are like a given. Okay, the magnesium, calcium, strontium, something like that. So they will skip the barium. So basically you have to find those. These are these, when you content the magnesium, it is not the triads. So triad basically whatever the elements. Okay, so Deborah chose, so that is the triad. So if you put the another element, so above the with the higher atomic weight or the lower atomic weight, so that won't be your triads. So triads composed of the specific elements, so that we need to remember. Okay, so the things is that, so it is like a chlorine, bromine, iodine, calcium, strontium, barium, lithium, sodium, potassium. Okay, again the iron, cobalt, and nickel. So what is the basis of this triad? So basically the triads are made based on their atomic weight. Either the atomic weight will be the similar, or the atomic weight of the middle element will be the average of the atomic weight of the first element and the last element of the respective group. Okay, so this is what the Drevonier he contributed to made the first periodic table. So this was the first attempt. Okay, so where we can get the idea of periodic table, or we could we could learn about that these elements are together, we could study their property and we can get the information about the elements. Okay, so then what is the limitation? So basically what is the limitation? So at that time when Devoranier started the work, actually the 31 elements were known to us. Okay, and out of 31 he could arrange only the 12 elements. So basically that is the four triads. Okay, so that is the driving force. Okay, so we could arrange only 12 elements after out of 31. So whether we could do it better, or we could arrange all the elements that are known to us. So with that intention, the progress started, and the modern periodic table, what we are having. So it develops step by step. In the next step, so another scientist, Newlands. So this is an English scientist. Okay, so he first arrange the elements in the order of increasing atomic mass or weight. So basically what he did, say he arranged the elements with increasing their atomic mass or weight. And along with that what he did, so basically when he arranged the elements with increasing their atomic mass, so he found that every 8 element had a properties of similar that with the first one. Okay, so basically if we start with 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the 1 and 8 will have the similar properties. Okay, so that is he compared with the sorry, that one he compared with the octaves, octave rules, and it was he compared with the music system. So if you think about our music system, so it consists of the 8 saragam. Okay, so in our music system, so basically we are having sa, re, ga, ma, pa, dha, ni. Again sa will come. Okay, that is what the music so it is same also, since the Newlands is from England, so they are having different the sargam. So that is these are the do, re, mi, fa, so, la, ti. Again do will come. So basically now if you see the 8 after 7, so 8 again this will be the do. Okay, so with that he tried to correlate things, and with this correlation he proposed the law of octaves, or the octave rule. So in that rule, so basically every 8 element, so if you here he actually started with the hydrogen. Okay, he started with the hydrogen, and then lithium, beryllium, boron, carbon, nitrogen, oxygen. Again, when it came to the fluorine, so basically the hydrogen and fluorine are having very similar properties. Okay, in the same way, when we talk about the lithium and sodium, so they are having similar properties. Okay, so this is the quite good improvement or achievement. So basically with the octave with the octave rule, so he could arrange the elements at the same time. So he put the another the term, so basically the atomic mass. Okay, so with increasing order of atomic mass, again if we think about this, hydrogen, lithium, beryllium, so basically the atomic mass, it will increase. Okay, so this is what he started. And then at the time, actually the 56 elements were known to us. Okay, so he started with his table or periodic table, or he tried to arrange the elements where he start with the hydrogen and ended with the 56th element. So that is the thorium. No, at the time when he was working, at the time the 56 no total 56 element were known to us, so that's why he arranged total 56 elements based on their the octave rules, and he started with the hydrogen and ended with the thorium. So this is important. Okay, like what is the first element in Newlands periodic table, or what is the last element? Okay, this is what he did, but no, it is not no very successful. So with our knowledge, so basically we learn that we are though there are many no elements that present in our no in the earth, or in our surroundings. So according to the octave rule, so basically these are the limitation. Okay. So why it did not succeed? So basically the limitation of this, actually he this law is applicable up to the calcium. Okay. So again we will learn later. So why after calcium it did not work? So basically this is the the S block element. So again when after calcium, so basically again the D block start, and then no they don't have no very similar properties, like it did not follow the octave rule. So that is why the after calcium the every eight elements uh, eight elements did not possess the property similar to that of first one. So because with time we learn, so there are the deep block metal, and we are having a large number of deep block metal, and they are having pretty much similar properties. So basically then the octave rule no it did not work for all these. So that is why no it is not applicable. Okay, so basically even he was working with the 56 elements, so basically up to calcium only his octave rule or a octave law was applicable. So after calcium there is no similarity in their properties of after every eight elements. Okay, so this is the first limitation. The second limitation is, so he did a big mistakes. Like at the time, only 56 elements were known to us. Okay, so that he thought that this is the number, or these are the elements only available in the art, or we won't have. He did not think about that we could have the more elements that yet to discover, or we did not get familiar with this. Okay, so that is the major disadvantage, is that he did not think about the more than 56 elements. So that's why no he arranged only the 56 elements. He did not predict anything about the availability of the other element. So that no that did not known to us at that time. Okay, so another big mistakes, like a to adjust all the molecules. So basically, so no so he adjusted, or he put two elements in the same slot, but they are they some unlike elements in the same group. Or so for example, like the cobalt and nickel, so they were placed in the same column of the fluorine, chlorine, bromine, which are having very different properties. So as we know, so with the progress, so we'll see the cobalt, nickel, they are very different. Okay, so their chemical properties will be very different from the fluorine, chlorine, bromine, that is no halogen group. So that is what another disadvantage or drawbacks. At the same time, the iron, which is resembles with the cobalt and nickel in properties, has been placed far away from these elements. So these are the advantages. So basically, even though copper and nickel, they are having very similar properties with the iron, so they were kept in a different place, and the cobalt and nickel, they are having very different physical and chemical properties, so they were kept in a same group. So that is what these are the major limitation of the Newlands law of octaves. And that too, again, when we discovered the noble gases, so actually then itself, again, whatever the up to calcium, he could explain the things, or the octave rule was applicable. So if you could later we'll see, so every the eighth element, so basically now it will change. So after the so helium, neon, so when noble gases introduced in the periodic table, so it become the group, we will have a new group, and that is why we added another element, and this law of octave, so that is no more applicable when we introduce the noble gas in the periodic table. Okay, so after that, the another person who came into the picture, so the person is the Lothar Meyer. Okay, so he tried to arrange, Lothar Meyer, he tried to arrange the elements with the by measuring the physical properties of the element. So what are the physical properties he measured? So basically he measured the atomic volume, the melting point, boiling point, of various elements. So after measuring all these physical properties, he try to arrange or give a shape of the periodic table, and this is what his result. Okay, so when he measured the atomic volume, he found there are metals like the lithium, sodium, potassium, and the rubium, cesium, so they are in the top. Okay, so basically they are having the highest atomic volume. Okay, and they are in the peak of the curve. Okay, so then when he measured the relatively less electropositive, that now it is known to us the alkaline earth metal. So basically the barium, magnesium, calcium, strontium, beryllium, magnesium, calcium, strontium. So they are in a descending position of the curve. So descending position, basically these are the, sorry, this is the place. So like this is for beryllium, this is for magnesium. Okay, and this is for the calcium, and these are the descending position. Okay, and the most electronegative elements, so that is now is known to us is the halogen group. So basically the fluorine, chlorine, bromine, so they occupy the ascending position. So this is like before sodium, so this is here we are having the fluorine. Okay, so again this is here in the chlorine. Okay, and here we are having bromine. Okay, so this is we are having bromine, and here we are having iodine. So now three points we could see that the most electropositive elements now, which is known to us now alkali metal, so they are having the highest the volume, and then the next or relatively less strongly electropositive elements, they are having the position in a descending position, basically the after the alkali metal, so this is going down. Okay, so this is how it is in the descending position of the alkali earth metal. And if you think about the halogen atoms or halogen group, so the elements, it is in the ascending position. Okay, so based on that, he tried to arrange the elements, and all are no based on their atomic weight. Okay, so two things he considered: the physical properties, okay, and the atomic weight. Okay, so along which are having the similar physical properties, they try to put in the same group, and whereas with the with the increasing their atomic weight. So basically they are in the horizontal line he tried to put. Okay. So, but this is unfortunate that now the Lothar Meyer actually, when he was working at the same time, the another person he is also working on the periodic table, or try to arrange the elements in a group, or in the all the place at the same place. Okay, so if the person is the Mendeleev, so the Mendeleev, so again, what he did, so basically their intention is very much similar, but no, Mendeleev he was little advanced. Okay, so along with the physical properties, he also measured the chemical properties of the elements, and he tried to arrange all these things, based on their, the atomic weight. Okay, and no here are the few things. So the characteristic of Mendeleev periodic table. So basically, he arranged all the elements according to their atomic weight. And when he was working with all this, the periodic table, so that time 63 elements were known to us, and the still noble gases were not discovered. Okay, so with this, so 63 elements, he to accommodate all the elements, so he make a table which contain the 7 horizontal rows he called the period. Okay, and the vertical columns, the 8 vertical columns he called the group. Okay, so basically, so it is like this. So basically we are having horizontal line, and this is the vertical line. Okay, this is the vertical line. So in the Mendeleev periodic table, he is having 7, 1, 2, 3, 3, 4. So we are having 7. This is called the period. Okay, so this is called the period, and these are the like a 1, 2, 3, 4, and the same way up to 8. So we are having the 8. This is called each, we are called the group. Okay, so to accommodate all the 63 elements, so basically he arranged first seventh periods and the 8 groups. So again, the questions may come like what is period and what is group. So basically the horizontal rows that is called the period, and the vertical column that is called the group. Okay, so along with this, so basically again, so he divided the each group into 2 categories. So basically a group, so basically group into subgroup. So basically the up to seven group, he divided into 2 subgroups, that is A and B. Okay, so A subgroup elements are called the normal elements, and B subgroup called the transition element. Okay, so this is what, now this is how he arranged all the 63 elements. And apart from that, so in the 8 group, so now we learn, so basically up to 7th group, or up to the 7th this particle line, so that he divided into 2 subgroup. So basically if we think about this, so this is one group, so this is one group, and this is again he made subgroup, this is A and this is B. So this is along with this. So again in the 8th group, for the 8th group he did not put any subgroup. So for the 8th group, this is the 8th group, so 8th group, so he did not put any subgroup. But in this group, so each period he placed the 3 elements. Okay, so that is called the transition metal group. Okay, so group 8, and these no the group was consist of 9 elements, no in 3 rows. So basically that was at the time, it was only the 9 elements were known to us. So basically that is what he did. He arranged the elements in the following way. So again we'll learn about, so basically what Mendeleev did. So he had contributed a lot. So basically he made in his periodic table he's having 7 periods. He's having 7 periods and 8 groups. So this is his main, and again each group is subdivided into the A and B, except group 8. Except group 8, he subdivided into each group into group A and B. So A group called the normal elements, and the B group is no the transition element. So these are the most no the contributing and the most successful model no at the time, at the time. So that is why no, and this is why no he gained the popularity. And most of the times now we learn about the Mendeleev is he's the father of the periodic table. Sometimes we call, but now later many people contributed in the periodic table, and we are having much better things than what actually the Mendeleev left. Again, the elements belongs to the same group exhibit the similar properties. So this is another the interesting thing. So that now we are having a table, and in the table we are having all these things. And now in the each group, so if we have a group, so each group we know these are having no similar properties. Okay, so this is the advantage. Like now we are having all the elements all together, and we can easily uh, understand their uh, their properties, their reactivity, and their no compound, something like that. Okay, so this is the presentation, or no, this is the representation of Mendeleev periodic table. So at the time, so again along with this that we told, he also studied the chemical properties. So basically he studied all these no uh, mm, the elements of their hydrides and their oxides things, the chemical they study the properties of this. Because why? Because those hydrogen and oxygen, they are very reactive to these elements. So that is what you can see. This is a each group up to seven group. So we are having group A, group B. So basically again in the group B, so these are the normal elements, and these are the no these are the, sorry, in the group, these are the transition elements. Okay, so this is nicely explained at the time. So but still it was not a complete periodic table. So basically again there are no view there are limitation, and there are things. But again, the most important things is that we need to now appreciate what are the things we can learn from this. So basically this is the first time all the elements that was known to us classified into groups according to their similar properties. So the study of the properties now become easier, because we know in front of in front of our eyes all the elements in it was present in a group or in a table. So another thing is that, so that is the another interesting part what he did. So basically that is the prediction of new element. Okay, so when he was trying to arrange the elements, when he's trying to arrange the elements, so basically he found that there are some uh, there are some elements, so actually that is not similar properties. And according to that, so basically when he tried to arrange, so he expect that there are some elements we are missing, and he left no space in the table, and he gave the name, and later we discovered, so these are the elements. So like the scandium, gallium, and germanium, and then technetium. So what are these elements actually in his periodic table? So this is he gave the name is the eka boron. Eka boron, this is this is a gallium, this is a eka aluminium, this is eka aluminium, and this is eka silicon, this is again the eka silicon, and this is eka manganese. Okay, so these are the, this is very important, like not only he kept space, not only he kept space for these elements, actually he predicted about these elements, and also mention or know the properties of these elements will be like this. Okay, so how would it be their oxides, how would be their oxides, how would be their chlorides, how would be their chlorides, and their melting point, boiling point, etc. So he predicted. And for the your competitive exam, this is very important. Okay, these are the very important. So what are the elements they actually he proposed that no, so at that time it was not known to know us, but no, later we'll find this no, these elements, and that this will be available to us no. And these elements actually the scandium and the gallium, germanium, and technetium. So these are the things. So basically, in the questions, it won't in the exam you won't see this kind of question. So basically, you will see. So in the mental periodic table, what is eka aluminium, what is eka boron, and what is eka silicon, okay, or what is eka manganese, okay. So these kind of questions will come, and you have to pick up the correct one. Okay, so basically, which one is eka boron, which one is eka aluminium, which one is eka silicon, and the eka manganese. So respectively, so basically, you have to remember, and so these are the most important the point. So frequently in the competitive exam, so these are the options they come. So now again, if you see, actually this is a scandium and this is a gallium, this is belongs to eka aluminium. So basically it is next, or it is the next period of this in the aluminium group. So basically this will be your gallium. So basically the gallium properties, it will pretty much similar, will be like a aluminium. So aluminium, it form oxide like a Al2O3, and gallium will also form a oxide like a Ca2O3. Similar, it is like a germanium. Germanium, it is just next to, it was silicon. After silicon, this will there will be germanium. So the properties of germanium, it will be similar to like a silicon. So if silicon, the oxide of silicon, if we know the SiO2, this is frequently. So the oxide of germanium, it will be ZeO2. So this is frequently appeared in the competitive exam, and this is very important. Okay, so what are the element mentally predicted, and what is their physical or chemical properties? Okay, so that is what we need to know, and this is very this is sorry. So this is very important for any kind of competitive exam. Okay, so basically we need to learn about their how their what is the chemical properties or the physical properties of this element. Okay, so individually, so they can be asked, or frequently no, it was asked that how they are related. And another great thing he did, so basically this is the correction of doubtful atomic weight. So basically at that time the atomic weight is to calculate by this method. So basically again the valency into equivalent weight. So in Faraday's experiments that we are familiar. So basically for the beryllium, the wrongly it was considered the atomic weight of beryllium is sorry, the valency of beryllium is 3, and based on that, so equivalent weight 4.5. So basically it was calculated the 13.5. So but it was not matching with the Mendeleev periodic table. So then he did not consider this one, or did not put initially in his table, and the later when realized that actually the valency of the beryllium is 2, and then no, it atomic weight is 9, so then it was placed in the periodic table. In the same way, the correction of the atomic weight were done. These are the elements, and these are the elements. So these elements, no, atomic weight of these elements were, got corrected by Mendeleev. So this is a great contribution from the Mendeleev. Okay, so apart from that, now we are having, so some demerits, or the limitation of the Mendeleev periodic table. So first of all, the position of hydrogen atom. So position of hydrogen atom, actually hydrogen again. So still, we have a issue with the hydrogen, basically where to place. So hydrogen, it's very much resemble with the alkali metal. So that is again the group 1A in Mendeleev periodic table, and it is very much resembles with the also the 7A, which we call the halogen. So it has very pretty much similar properties like a alkali group as well as the halogen group. So his position was not conclusive where he should put. Actually, he could not decided where to put the hydrogen no in the periodic table. So that is the limitation of the Mendeleev periodic table. The second one is now the position of the isotope. So when we learn about the atomic structure, so basically then we learn, so basically the same element. So when same elements having different mass, so basically the at different atomic weight, atomic weight, but the same proton number we called proton number, or the atomic number we call the isotope. So basically now we know, we knew that the hydrogen has three different isotopes. So basically this is H1, and this is D, deuterium. So basically this is 2, and the tritium. So basically this is is to write T. So these are the isotopes where the atomic number are same, but the atomic mass is different. Okay, since atomic mass is different and the Mendeleev periodic tables note, so he arranged all the elements in with increasing their atomic weight. So when we are considering the hydrogen, so it has a different isotope. So basically it has a 3 isotope. So where to place all these isotope? Okay, so he did not talk about this. Okay, so there is no place for such isotopes in the Mendeleev periodic table. Okay, so this is that demerits or disadvantage, and this like a the anomalous pair of the elements in their atomic weight. So again, so he arranged all these elements according to their atomic weight, but no atomic weight. But when we see there are no few cases where no the argon and the potassium, the tellurium, iodine. So these are cases so where you can see the atomic weight of potassium is no lower than the argon, but still argon is ahead of potassium. So basically this does not follow the atomic weight the atomic weight consideration. So basically whatever the elements we arrange based on their atomic weight, so that no did not follow for these kind of pairs. Okay, so from their atomic weight we can now see, so these are not these are like a different or exception. So where the lowest atomic mass is placed after the this relatively high atomic weight. Okay, so along with this, so he also, the Mendeleev also, he put some elements, so where the properties are they don't have no the similar properties. Okay, so basically here the elements like the platinum and gold, okay, which are having the similar properties, but no, they are in a different they are different groups in Mendeleev periodic table. So this is, we can see in the, if you could remember, so basically platinum is present in a group 8, which is group 8 content 3 elements, or and again the same is true for the gold again. So basically gold, if you see, it was placed in a alkali group or group A in the, group 1b. So basically, even though the platinum and gold, they are having pretty much similar properties, but one was placed in group 8 and another was placed in group 1b. So at the same time, so we can say in other ways. So basically, where even though the gold, so they are having, these are having very different properties with the alkali metal, but still they were kept in a in the same group. Okay, so these are the limitation of the the Mendeleev periodic table. But even though, so it was explained nicely, so basically the most appreciating thing that the it he predicted about the few elements which was known. Now later we realize, and these are the things available. So now we'll learn about the modern periodic table. So how the origin of the modern periodic table? So it was started with the Mosley. So Mosley, he was studying actually the frequency of how the X-ray frequency, it it depends on the metal. So actually he started in the atomic structure. If you are familiar, so basically he started with the 38 elements and study their X-ray properties. So then he found what he found, the interestingly. So he found the square root of frequency, which is square root of frequency. So that is which is related to the effective nuclear charge. So that is we call the Z. Okay. So this is not with the atomic mass. Okay, so the frequency of the X-ray, or the square root of frequency, it was related with the effective charge of the element, not with the the atomic weight. And then later, this is effective nuclear charge. So basically, then he turned this one is a atomic number, atomic atomic number that we are familiar with the Z. Okay, so this is a number of proton. Okay, so this is how the atomic number, or the idea of atomic number we got. And then in the modern periodic table, so basically we arrange all the elements so in terms of their atomic number, not the atomic weight. So basically the physical now we with the modern periodic table, so basically the physical and chemical properties of the elements are periodic function of their atomic number. Okay, so not the atomic weight. So then again we'll see. So if we do like this, so the many things we could encounter, whatever the limitation we face. So basically now we arrange all the elements now with increasing their atomic number, and after a regular interval, so basically elements will have similar properties. Those are basically we call the periodicity, or and the periodicity, it is like a the again we learn. So basically the repetition of the properties of the elements, so after regular interval, when the elements are arranged in the order of increasing atomic number, so that is called the periodicity. Okay, so this is what we learn about the modern periodic table. And then the characterization in the modern periodic table. So basically in the modern periodic table, now we are having no the noble gases, and in the new modern periodic table we are having now, this is 9 vertical column. So basically 1 2 3 4 4 and 9. Okay, and we are having the same like a 7 horizontal. So that is the periods. Okay, so now we are having nine group, and after the eighth group, whatever the inert gas we introduce, so that is it is known to zero group. Okay, and this is another important point, that inert gases were introduced by the Ramsay. Okay, so he's the person who first he introduced all these inert gases into the periodic table. So in the modern periodic table now, how the modern periodic table form the Mendeleev periodic table. So basically in the Mendeleev periodic table, so we are having eight vertical lines, and in the modern periodic table we are having nine. Okay, so this is the questions you may expect in the competitive exam, like in the modern periodic table, how many groups and periods are present, how many periods and groups are present, so and how many, so then you have to read the questions very carefully. It was which periodic table, whether it is a Mendeleev periodic table or the modern periodic table. If it is a modern periodic table, so then we are having the nine vertical lines. If we are having the Mendeleev periodic table, will have the eight the group or vertical line that no uh, that contains like 1 to 8. And if it is a 9, what is the ninth vertical line or ninth group? So basically a zero group. Okay, so in the next class, so basically we'll learn about the long form of periodic table, so where we'll see the present periodic table we are using, so which is not like a 9 group. So basically we'll have the 18th group, and we'll learn about the details of the all the elements. At the same time we'll learn about the tricks, how we could remember the most of the elements with a very short time. So thank you for your attention, and we'll see you soon again.